Hey, everybody, it's Lester Martin from Starburst. Hope there's a good crowd today. We had a really good crowd 2 weeks ago. We did the first of a three-part webinar series that I'm going to do here on Trino query plan analysis. Um, and I'll cover some of the stuff lightly, what we did, just in case this is your first one here today. You missed the last one. There is a recording, so if you watch today live today, or if you're watching this as a recording later, there is a recording of session number one, and I encourage you to watch these three in order. I'm a little bit meticulous about query plan analysis. I think a lot of folks are looking for number three, but I wanted to cover some background and make sure we're ready for number three. All right, so let's go ahead and turn the page. And as I said, my name is Lester Martin. Definitely take a look, see if you're interested there. Probably the biggest thing to note is there's an email address at the bottom there that says devrel@starburst.io. If you send that message to that, you can find myself, a few other folks. In addition to me today, I have Monica Miller in the background from our product management team, a former leader of led the whole DevRel organization for a long, long time here for us and doing great things on our product management team. So she's going to be behind the scenes watching chat, maybe letting me know if I'm forgetting to turn the page or something crazy like that. So don't hesitate to ask and know that someone's taking a look. And for sure, we will have a little time left. I purposely made all three of these about, I blocked an hour off, and I anticipated to do less than an hour of conversation and give us a little bit of question time. All right, so last time, what did we talk about? Well, we talked a lot about parallel processing fundamentals. What did that really mean? It really meant, this picture here. It said, hey, can I think about a query that's joining orders and customers on an order key, something like you see down here? Can I see the joining occur here? Can I see maybe we grouped them by, we enrich the orders with the customer's medallion status or something, and maybe we grouped them by the medallion status, trying to find, does gold have bigger orders than bronze, or so on and so forth, and we ultimately, did a sorting on that as well. So if that picture makes a lot of sense, either because it just makes sense, or because you showed up last time and it made sense because we talked about it, that's the environment I'm hoping you have already today. So if you don't have that, that's okay. Hang around, because what we're going to do today is, and that material is available again, already recorded out there on our gate here. We have a YouTube link directly, all kinds of places. If you can't find it because of our messaging, just reach out to that DevRel, go to our YouTube channel, whatever makes appropriate sense. You will find it, or I'll help you find it. All right, so today what I'm going to focus on, as it says there, is the syntax of a query plan. So we're going to take that fundamental picture, lay it all out, and say, okay, how does that picture get represented in text primarily? We'll see some pictures too, but we'll focus on the text of that. So fragments, exchanges, fragment nodes, types of exchanges. That's the kind of stuff we'll talk about as we get here. And then at the very, very end, we should have just a few moments. I'll get a teaser for what we'll do in 2 more weeks, which is nonstop, nothing but run queries, look at query plans, talk about them, find problems. And I think that'll be a really fun session as well. So however you're consuming this today, I do encourage you to watch or consume the previous one, finish today, and then absolutely we'll see you in 2 weeks as we really dive through and really tear through a bunch of good stuff. All right. So for all that stuff to work, there's a couple things that have to happen. Behind the scenes, there's an engine here, right? There's a SQL engine. That SQL engine uses a thing called a cost-based optimizer, or CBO. It's really just a planner. It's the person that's figuring out what's the best way to tackle our problem. How many of those stages that we talked about? What kind of exchanges between the stages? Ultimately, how are we going to, in what order do we do work and activity? And to make that cost-based optimizer even have a shot out of the gate, especially when we think about Trino and Starburst and other engines that sit on top of Trino, the fact that they can connect to a lot of different kinds of data sources. We like to talk about, and I love to talk about, the data lake primarily, but there are other systems out there we talk to as well, including just relational databases and other things. And that said, table statistics about individual tables, just high-level statistics, are valuable. These are things that exist already in databases too. We want to represent them. And if you kind of glance, or you might notice, what you're kind of seeing is, hey, if you ask for some statistics for a particular table, it's just going to list out the columns and then tell us some high-level information, usually ranges, distinct number of rows, distinct values, that kind of good stuff. And you might think, that doesn't help me, does it? It helps a lot. And in fact, the very last record that says null says, hey, basically, how many rows does this thing have? Now, statistics are not perfectly always accurate. They are representations that were calculated at some point in time and stored. And depending on what we're doing and what system we have, they may actually sort of kind of keep caught up as we go along. But for the most part, we do have operations that say we could force them to be rebuilt or recalculated. We can say, hey, system, look at that particular table. And I'm thinking about that analyze that you're seeing right there in the middle toward the bottom. Hey, analyze this table. That means calculate the statistics. And what's nice is statistics, you saw they're going to list all the columns. The bigger the tables we have, the wider the tables we have, tens of columns, hundreds of columns and beyond. The reality is we don't always need statistics at every single column. We need statistics that impact our queries in some way. So there are things more than just a payload. Anything we're doing a where clause on, anything we're doing a join on, a group by on, things like that. Those are the columns we care about most. So if we're coding in our pipelines, if they're periodically recalculating statistics, we can be intelligent on our really, really gigantic tables. Now for, the hundreds and thousands of really tiny tables, and tiny means millions or tens of millions, maybe even hundreds of millions of records, maybe who cares? But on those really big tables, let's be intelligent about what we're asking for to be calculated. And we can, if we do a good job with the partitioning strategies, we can actually just ask particular partitions to be looked at. We don't want to waste time looking at things, calculating things, and storing them. And what do I mean by good partition strategy? Well, send me a link and I'll send you a blog post on lestermartin.blog that give you some real good examples of what a good partitioning strategy should look like. But the trick is, it means we don't have to keep coming back and recalculating statistics. Probably your partition settles down at some point in time. All right, didn't hit on it, but there you go. That's how we ask for those statistics. Again, why are we doing all this? Well, we want that optimizer inside of the engine to look at those statistics, because when it gets a query, it's going to build a plan, an execution plan, remember from last time, that really just honors the way you typed that SQL statement. Do this, join it here, do that. And it goes, okay, I can do that. That's what you want me to do. But then it's going to say, hey, basically, based on sometimes more than just those statistics, but absolutely to start with, it's looking for those statistics and trying to make choices about how it might better do that. So we'll spend some time trying to suggest some of those scenarios. We'll jump a couple forward. What are we talking about? Well, generically, a lot of times people think about concepts like push downs, or even, a couple years ago, we couldn't stop talking about the predicate push down. But those are good examples where we're saying, hey, look, there's enough in this query that helps me determine, and based on that metadata and all that kind of stuff, it might make sense to either, if it's a relational system, maybe I'll do some additional checking or where clausing that I push in there, or on our data lake, when we have intelligent systems, of course, file formats like work in Parquet, but the table formats like Delta and Iceberg, we can actually do something in that connector that is, in essence, a predicate pushdown. We can just get the metadata that's deeper in the system and say, hey, give me just enough, looking for little bits of data. The whole mission is to do less work. That's really what we're talking about. There's a variety of the quote unquote pushdowns. We'll see a couple of these as we talk about today. And then maybe, just as an example of another more advanced feature, and I'm going to show you this one, I think so, at the end of the day, just briefly. I don't want to explore dynamic filtering. I can definitely give you a link to this nice blog post that explains this one, but it's just showing you as an example that if there's a query down here that says something like, hey, if I'm selecting from things like a sales table, or maybe an orders table and an items table, one approach says, well, if you look, there's a where clause on the item price. One approach is, of course, do things like read the small table, broadcast it. We talked about broadcasting last time. It's a way to intelligently do a join by forcing up into memory the smaller table, and then we run through the large table, in a very, very parallel fashion. Well, the engine can look for things like, oh, you got a condition on your smaller table. Maybe based on those statistics, I can make a hunch that, you know what, there isn't that many records that meet that criteria. Maybe it says, oh, hey, what's the min and the max of item prices? Well, the minimum is like 20 cents. The max is $1,200. Okay, what's the median? What's the 6, 70, 80, 90th percentile? I might realize there's very few items overall that probably fit that. And it might be able to say, well, I've got billions, trillions, or whatever orders. So what a dynamic filter would do, just to stop talking about it, Lester, is it might say, hey, you know what? I'll set a plan up that says before I run the big query, I'll actually run at runtime. When I get done planning, I will say, go get those values and then build a dynamic in clause that I send to maybe my larger table. And now my workload got significantly smaller. So if it could all of a sudden decide, hey, you're probably going to read 10%, 5%, even 20% would be okay of the larger table, we're going to go faster. Less work usually equals faster. What are some other things? So these are I probably should have said these are kind of the easier ones. We definitely talked about this concept last time, a broadcast join versus a distributed join. In a nutshell, if you don't remember, it's that in a classical distributed join, you're going to read data set 1, you're going to read data set 2, and then you're going to shuffle that information to a third stage that will do the actual join. And a broadcast was like, oh, can't I read the smaller? If there's a small enough one that would fit in memory, read it, push it into memory, and then let us just read in parallel the big guy. It actually saves a gigantic stage, but more importantly, it saves the broadcast. It saves the exchange. It saves us reading a giant data set, moving the same giant data set just to read it again for a join. So the system can do that by just looking at how many rows in there, how many columns, did you only want a few of the columns, what are the types, and it can go, hey, I got an idea of what that looks like in memory. And we talked about last time, that's controlled by the fact there's a property that says how big is too big. So this is a pretty normal pattern. And as we talked about last time, someone said, do I have to give it a hint? Nope. We want to do broadcast joins as much as we can. They actually save a lot of work. So we do them. What's another important thing that happens to happen? My son is doing this big data analysis boot camp. I'm proud of him, so I'll plug him for a second. You got a job, let me know. I'll put him to work for you. But the person said, oh, it doesn't matter where you put, which table you put first in the join. And arguably, it's 2025, and we shouldn't need to matter. We do that. But that said, remember what I said, an engine's going to read that, or our engine, Trino, is going to read your join, and is going to read in the order that you put them in, the left side, the right side. Those matter to us. And if we don't have statistics, we don't know any better. And if we don't have statistics, then you better do the good job of putting the larger one in the right place. So what this ultimately does is lets us say, hey, there's some huge impacts about joining two tables when one is much bigger than the other, the way Trino works, at least. Absolutely. So this just lets us move things around the appropriate order. And then the last thing is just trying to make the point, all these things are in conjunction. Broadcasting, reordering, dynamic filtering, just to name a few things to kind of get you the vibe of what we're talking about. So for generally speaking, what happens often is you say, do you have stats when you're worried that your system is slow? That's always a good thing to check for first. Show stats. And in fact, if you're got time to kind of play with it, calculate the statistics again, run the query again, see what that did, see if the engine had a better shot at solving your problem. Yeah, there's a great question. I told Monica, I wasn't going to stare at the chat. Is it possible to see some real examples of Starburst doing push down and dynamic and filtered? Yes, that's going to be episode number 3, 2 weeks, but I expect to show you one or two of those. One, probably. I'm going to, at the very end, just to get the teaser, I got a pretty good query joining 3 tables, the aggregation and some sorting, and I'm going to run that. And I'm going to go look at that query plan, and I'm going to say, hey, what I want you to do at the end of session 3 is to be able to do this. And then I'm going to walk that plan, talk about why things happen the way they did, and show you that, it looks like a lot, but at some point you'll get to the point, nah, it's not a lot. I can kind of see through the matrix. So we're going to see that, at least a shot of that at the end, and that's absolutely all we're going to do in 2 weeks on session number 3. Great question. So, if you know all this, great. See you next time. If you don't, hang out with us. I'm not going to go through that picture again you see on the screen here. This is something I'm hopeful that the audience that's here today already has some awareness of the fact that, Trino has a coordinator, Trino has a, one or many potentially scale upable, scale downable workers. Humans or processes are asked the coordinator questions. We validate, is that appropriate person? Is they, ANA, authentication, authorization. We get that metadata that we're talking about. A lot of that is statistics. A lot of this, what we're talking about, is those stats there. It's not only that, there's more to it, but those are some of the basics. And then, the coordinator figures the work out and says, do it, puts the work down on the workers. That's kind of, backdrop of what the engine is doing. And more appropriately for what we're kind of talking about is this. This is the really quick window where the coordinator is doing all those things to figure out the solution. So the bottom stuff down here, this is the do it, but the top part there is something that should happen all very, very fast, right? Get your query, parse it down, validate those statistics are present, figure out the best plan that will satisfy and arguably what the coordinator believes will be the best plan. We don't know until we run. And it's a good point to make here that statistics matter. I said without statistics, the optimizer goes, I'll just do it. I don't know. I'll just do it your way then. But someone once told me, and I disagreed heavily, said, Lester, bad statistics are worse, or old statistics are worse than no statistics. I would argue that's not really true, but there are scenarios, and that person had a scenario that I won't go into great detail on here, that could be true. So in other words, statistics matter. And if we think things, for example, could fit into memory, we say, that table only has 1 million rows. We'll do a broadcast on that, but it has 1 trillion rows now because you ran statistics one time, like when you loaded one file and tested it, and then you loaded billions of files, and then it went, statistics don't need to be updated. We'll get it out of memory exception. We're going to try to push that thing into memory. So statistics should be relatively current, relatively accurate, or better than relatively. But if they're dramatically wrong, there could be a few scenarios. But I digress. I move on. So all that happens, again, hopefully all that happened like in a second or less, and I'll show you when we run one, and we'll see it definitely next time. I'll link those times every single time. And then the work is the bottom stuff. Okay, great. Run it to ground, finish it up. All right, what's some more interesting ones? And I debated leaving this here in here. I always struggle with this picture because I think sometimes it freaks people out. But I want to talk about this for a brief moment. Remember, if you were here last time, I said, well, what if we talked about things like a pipeline of operations. We talked about how a join could do things. So here's what could be happening. Those little circles are those little operations that are pipelinable. So maybe example, the thing on the left is selecting from orders, for example. And then maybe it's also filtering down only ones that are over $100 or whatever. And then maybe simultaneously or somewhere around that same thing, maybe someone's reading a task that says, scan the customer table. And then from there, just project out the medallion status. But ultimately, they need to do a join. So what they're really saying is, okay, you know what I want to do? I want to exchange that customer ID. Why? So I can have another little action or task that does a join, and then maybe another action or task that does something else, and either a group by or order by or something. I said all that. Why? Because those operations, and I debated putting that slide in here. I think I left it out purposely. Yeah, I did. This is the one, if you want to look back, it's the one we said, we showed a select statement. I said all these things, the select, the parse, the where, the uppercase, all that stuff happened, in a stage. So what's happening once this gets figured out, it says, what are all the interdependencies? And then the optimizer says, okay, good. I see that these are things, back to that word I used before, mutually exclusive. So it does line up all the work you want to do. Then it starts mapping around that, the stages, which mean extreme parallelism, right? No need to do shuffling. So these are just do it, do the next one, do the next one. And then it says, oh yeah, these are going to have to exchange. Oh, there we go. There's another stage. And hopefully we have a 2 or 3 operations we can do in each stage instead of moving on. But that's really what's happening. So it just kind of visualizes the fact that there are little micro units of work, and then those units of work are put in those mutually exclusive pools. Can I do this, this, and this on record 1, 2, 3, and 4 on record 1, and then do it again on record 2 and record 3? Yep. And then ultimately after that, the rest down here is just, okay, good. Now I've got a plan, as you saw in the previous one, the lower half. Send it off to the workers and run it to ground. Very fun stuff, pictures. All right. Before we go a little further, I want to use the nomenclature again, because we said some terms last time, and I tried hard to make sure those terms were, conceptual, but they had the words that we use in Trino. And this is right off the Trino's doc page. When you say, tell me about a query plan, it starts with this. This is where docs start at. It says, hey, remember these things. Okay, well, not remember, this is the explanation. So some of those I'll remind us, we remember them. Statement, that's the text you send. Select this from that, join this from that. What else is there? Well, there's a query. Well, the query is really the statement. It just means it's legitimate. So behind the scenes, we differentiate statement and query, but it's the query that you're asking for. What else is here? Well, another big one is this word here, split. We talked a lot about splits last time. This is the monument, the fundamental element of how we do parallel processing. It means break a data set into splits, chunks, partitions, pieces, whatever you like to call it, so we can operate them in parallel. Okay, so that's the split. What do we do with the split? Well, actually, those little bubbles, those little activities like a scan, like a filter, like a function such as uppercase or lowercase, as a simple example, those are operators. A join is an operator, a group by is an operator. So all those things are operators. And really what's going to happen is we're going to say, okay, what are that little bitty pipeline of things that we can do at once by looking at a first record? This is that parallel processing. So basically, terms you won't hear a lot of these two, drivers and operators. This just means for a given split, I'm going to run this collection of operators, kind of think of it as a driver. But I want you to not worry about driver and operator too much. Let me unhighlight those a little bit. Think about query, think about split. But what are we going to do with those? Well, we're going to, assign to a worker, a single worker, all of our workers. But for each worker, we're going to give it a task that says you work on one or more splits. And this is the subtle one I mentioned, that like the other engines, usually a task is linked to a single split. Ours is a task has many splits. So you can, back to that word I said, don't worry about a driver's more like one of those tasks you might think of in like a Spark or something. So tasks are going to usually be the number. How many tasks? Usually about how many workers I have. But how many splits? How big is the data? And then what is all that going to happen? Well, all the tasks, all the workers working together are going to do a stage. So stage is really the chunk of work on a split. A whole bunch of splits are simultaneously working and doing what? A series of operations, a driver full of operations. And when they're all done all through, they're going to exchange data. Where? Probably to another stage, or likely, if we're lucky, we're all done, we're going to give it all back to the consumer. So what am I saying? State query, I guess really stage task split, exchange. Those are the ones, if I had to say what matters the most, what to remember, let's remember those. Exchange, a split, stage, and a task. Yeah, those are the words that we'll be seeing as we get a little further. Okay, let's do it. Let's get a little deeper. Okay, why do all this? We didn't talk about last time, but I think we got it. What are we trying to get at? We're actually trying to find out, sometimes we just want to know how it works, but we're probably tackling things like that. Hey, what's going on with my query? Now, this could be a query that's been running for some time, and now all of a sudden got slower. So those are easier to solve because you usually have a pattern of something good. Now we have something bad. What's sometimes a little harder is just, okay, I came up with a query. I figured all my logic out. That's what I want. It's the answer, but Can it go faster? That's another one. So we're going to use things like the query plan, the explain plan, the query plan, and we use those terms universally to say, hey, is there things in here? At least see what's taking the most time. See what those high pulls in the tent are, and then decide, are there things that we can do to make it a little bit better? I would say the reason to learn all this is, well, I think I said it last time, the person who understands an engine is the person who can give you some real feedback. Can it be better? Will it be better? What can we do? And we need a couple of those people. We don't need every single data engineer to be a Trino query plan expert, just like every Spark programmer doesn't need to know massive internals, but it doesn't hurt to have one or two for every 5 or 7, 10. Let's say at least one person for every 10 people. It'd be good to have that kind of ratio. And it would be good for everyone else that's knee-deep, data engineers, maybe not data analysts, but the data engineering team, they're on the hook to make sure these pipelines go fast, these queries that run the dashboards go fast. At least want them to get to the point where they can do what we're going to do next time, walk through and read a query enough to go, okay, or at least see where the slow moving parts are. They want to learn that. So the person that understands something is the person that can probably help you out when things get tough. All right. It's a world of AI. Maybe this time next year, all this is magic. We just ask our co-pilot, "What's wrong with my query?" and it tells us. And that's not unreasonable because there is this knowledge. We just need to get it into these engines. But today we still get to do a little bit of this. All right. So what's an explain plan? It is that visual picture we saw earlier from a query. So there's our query, and this is a textual representation of the previous pictures that we talk about here. And I would say what to look for, and we could just spend the rest of the time on this one slide, but I'm going to kind of slice it up in bits and pieces and just introduce a few concepts at once. The one I want to say right now is this. If you remember, when we looked at our picture, we said, read from the bottom up, visualization, right? This is a source stage. It's reading data from the data lake. This is a joining stage. This is a sorting stage. These are the same thing. These query plans, you're going to go to the bottom, and they actually left justify. Anything that starts on the far left, that's a stage. And sadly, it doesn't say stage, as you'll see when you look really close. I'm going to get the font bigger. It says fragment. So for us, we're not going to get into the religious argument of, is one of them an instance of an item, another a fragment is a stage is a fragment for 99% of us. Same thing. So choices in the terms, it'll say fragments. So much of the GUI will say stage. The textual stuff say fragments. So this says, I got one here called a fragment. I got another fragment. I got another fragment. And I got another fragment. What do I have? I have a 4-stage job that outputted there. And if you look really closely, as you're going to see in a minute, they're numbered. And they number, they end with 0. This guy's a 0. And as you go down deeper, you'll see that 1, 2, 3. So if you want to know how big your job is in stages, one easy thing to do is look at the query plan, scroll to the bottom, and grab that number where it says find the lowest fragment, the bottom fragment, and look at that number. That one says fragment 3. You can't see it, and add 1. Oh, it's 4 stages big. Why is that important? Remember, stages are this is the heartburn of how this stuff kind of works. All right, we're going to see all this other stuff as we go. How do you get one of these? You just type either explain before your query and then run explain with your query, or you say explain analyze, which will actually run your query, and then it'll also run your query and then give you the same output, but with some additional details. One of them will give you the plan of attack. The other one will give you the plan of attack with the details. What's another way? Well, if you're using tools like Starburst or even the Trino UI, you can go back, run a query, and guess what? We're going to hang on to, for Starburst for a long time, for Trino not very long, we're going to hang on to, guess what? The query plan for you. So we're going to capture that output of the explain analyze anyway. And this is the one at the end of today I'm going to walk us through. If I scroll to the bottom, what did I tell you so far? I said something like that. Oh, go to the bottom. It says fragment 6. So this is a 7-stage job. There's 6, there's 5, and I'm going to come back and see this one again. It should look, if this is new to you, it should look like, oh, I don't want to touch that, Lester. And that's okay. I'm just going to show you that you can look through it pretty fast and go, oh, I see what, even if you didn't know the query, you can figure it out. Now with the query and the plan, it probably makes more sense, but we'll see that today, and we'll beat in next time. Like I said, that's all we'll do. We'll live in that world 100%. All right, so you can type explain or explain analyze. They'll kick it out on the screen. It's just that if you type these, you're not getting results. You're getting the plan. Let me just drill that point home real quick here. Run my query. I'm going to put the word, instead of just run, I'm going to say explain it. And then I'm going to run that, all of that together. See down below, you got the actual results. If you said do an explain, you're getting voila, the explain plan. And just as much if you say explain analyze, you're going to get the explain plan again, but I'll show you in a second. It's going to fill in numbers. So it's really going to run it, calculate all the results. So this one's taking a little more. I had to figure a plan out and then run it and then inject the results into the plan. So let's look at that. All right. Easy to create, easy to calculate, easy to see it on screen. Again, there we go. Just a little bit bigger font, same thing. So this thing says go to the bottom. What did I say? It has a fragment 3, so it's a 4-stage job. Let's talk about a little bit more. And all these are valid with the queries at the top, but I think it's better to talk about some of these breakdown pieces. I said there's something magical about explain versus explain and analyze, and it's really the stuff pre-highlighted in yellow for me so I don't have to use my pen. And it says, guess what? The thing on the left told me what I'm going to do. That's the explain plan. The thing on the right injected, because it calculated that plan, and then it did the work. So by doing the work, it actually knows how much data was read, how long it took doing it, how much stuff had to get exchanged around, what's the overall averages. It's injecting in there the actual performance and the output activities. And again, if you're using a tool like Starburst, it's happening already. I mean, it's being not just happening, it's being recorded for you and hung on to for some time. If you're naked Trino, there isn't a long durability of that stuff. It hangs around for a little while in the coordinator, but it doesn't stay around for long. We persist that somewhere. So an open source Trino, they don't have like a long-term history server. You have to do something for that. There's, in fact, I digress. I'll stop. Yeah, good stuff. Let's keep on going. Oops. And important, if you remember, we read from the bottom, we work our way to the top, and we had all those pictures that said, oh, there's arrows that show we're exchanging from this to the other. Well, the good news is all that does exist in the textual representation too. It just says, hey, this fragment number 3 did something. We're going to talk about that more, but it actually sent some data, exchanged it, but we kind of read it the other way around. We say, okay, we're looking at fragment 2. We kind of look at the bottom and say, hey, what did I get data from? Oh, I got a source of data came from fragment 3. So 3 goes to 4, and then as you kind of see here, 2 ultimately goes to 1, 1 goes to 0. And this is a simple query plan. Do something, do another, do another, do another. And the only reason there are stages is because the thing is so hard, such as a group by, that it can't do it in perfect parallel. It has to kind of reshuffle the data, as we talked about, and send it to another, reshuffle it logically and send it to another piece of work, and then reshuffle it and so on and so forth. If they are 3 goes into 1, we're going to see some of that. Even today, we're going to see that, yeah, these 3 things all belong, or usually probably 2, but it could be 3 or more that come together. So you can take that text and kind of sketch something. I'll go ahead and tell you the good news is you don't have to sketch it. Let's just look while we're here. Let's get rid of the analyze and just run it one more time. Because, hurry up and run for me here. Boom, 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 run. Those pictures. So, again, I can come here, I can see that long thing, but I think what's nice too is I can go back to this tab called stages, and I can see, okay, these are just textual, but there's a nice little graph button over there. And we touched on this last time. We can say, cool, show me what's going on, explain it in greater detail. So this is a complementary. This is somewhere between what we did last time and what we're doing this time that says, hey, what the heck is happening? And it'll be nice. It'll actually have all the numbers and statistics and details. And I'll show you this very query plan at the end. Again, not to master you do it today, but to show you what I expect you'll be able to do by the end of the 3rd one. So video, these first 2 sessions in that. All right, so it is all there. It's out there. Yeah, exchanges. What's another important thing to notice? I'm going to go back one slide. And if you look really close here at each one of the fragments, to the side of them, it says something like, it's got these little brackets. Let me erase that. Here we go. If you look really close, you'll see that each one, put my highlighter back on here. Yeah, they have a bracket source. Whoa, what did I do? Neat. Bracket hash, bracket round robin, bracket single. So that's what it's talking about in the next slide. It says, hey, these are the distributions. The heck does that mean? I see a question I might look at in a second. What it means is, how did I get data? How did I get data? Now, there were only a handful of these. And if you remember when we talked originally, I said, hey, the very first stages that operate are kind of special. They get data from data, right? They go to our connectors, such as the data lake or Oracle or whatever, and they bring data. What do they do after that? Then they exchange it and send it somewhere else. But one of the ones, in almost always toward the bottom, you're going to see the very lowest or the lowests, there might be more than one, have bracket source. That just means I'm reading from a connector. And we'll look in this one a little harder, definitely more. But if you look a little higher, they kind of made the point, hey, this is reading this table down here called catalog glue, schema boot, plan explain, and then table orders. Okay, he's doing a scan, filter, project of that table. It's a source. But there are others. And it's read not about what I produce, it's read about what I am receiving. So sometimes the words are kind of done a little backwardly. If you really look closer, it'll actually say, what am I going to output? I'm going to output a hash. So whoever's receiving fragment 3 will probably say fragment 2 hash. I'm getting a hash. And at the very bottom, I'll say I'm getting it from fragment number 2. And I think if I don't show that the next slide, we'll go back and look at it. Yeah, let's go backwards and make sure we see that. There we go. So fragment 3, it's a source. And while I took it out, buried in these dots, it says, hey, I'm going to exchange my data via hash. So we look at this guy. He says, oh, I'm getting data from 3. And what am I getting it as? I'm getting it as a hash. So if you're a programmer, these are just contracts being replicated all over the place. And they are a little weird how you have to read them. But they actually, believe it or not, will get pretty. If you look at this somewhat regularly, you'll go, yeah. That makes a lot of sense to me, Lester. All right, so we'll see some of these other ones, why they're important. So source probably makes sense. Read it from a connector. Hash probably makes some sense. We called it, if you remember when we did a join or we did a group by, we said, hey, we have to force all the unique values, all instances of a unique value to a single split in the next data set. That's a hash. So anywhere you're going to do something like a group by or a join, we're probably going to output this via hash. All right, let me take a moment and see what's questions here. Might having a question be stuck in the planning phase. Yeah, if you have somebody, Brent said, what if I got a query stuck in that planning phase for a long time and nothing else is happening? What can I do? Well, for early, it's going to tell me is a couple things. Number one is probably that we're getting stuck working with that connector, getting the necessary metadata that we need to then make the plan. And that sounds like an easy fix. Okay, what's wrong? It's not always that easy fix, but it is usually the problem. Once we have all the metadata we have from everyone, we should be able to wrap it up pretty quick. We have everything we need. We're just running through code. So there could be something else going there, but I've seen that a few times, especially not to pick on Teradata, but those are the kind of example ones I've seen where a query was taking 7, 8, 10, 12 seconds, but it was really taking about a second or two to run. It's just that we got stuck in this routine and we had to work with that administrator. It'd be different if it's a Delta Lake. So we'll have to look at that in each one, but usually that's what I see it happens to be. We're having some metadata pull issue. And there are things we can do in Starburst and Trino land. We can say, hey, for this connector, maybe there is a problem. Maybe that system just takes a little time. We can do things like caching of metadata for brief periods of time. So, even a few seconds sometimes can make a giant difference, or maybe 30 seconds or something. So there are tricks that we can tackle around that, Brent. Is it a good practice, Jacob? Practice to some metrics from each fragment to get an idea of the total query. It's a good practice to sum the metrics to get an idea of total query. I would say if I read the question right, Jacob, the table statistics are probably what I think you're saying. They are the overall across this whole table. But maybe I'm reading it wrong. To some metrics. If you mean how much work, how much time, physical time, clock time, CPU time each stage did, we are going to see that that does exist if that's what you're asking. So definitely the output's going to show, the explain analyze is going to show what took time, where it was at, all those kinds of things. Okay, yeah, CPU memory usage exactly. So yes, we are absolutely going to see that, and we'll use that. I'll show you some more in a second about it, but I kind of hit it on there. And it's actually, if you look really deep, these things are called fragment nodes. Each fragment node is going to tell you, down that level of detail. So they're going to, each one of those operators that I talked about that work in a mutually exclusive kind of read a record, do it. It's going to show you of the three things. So it had the three operations, this one, and this one. If you look in there, you'll see CPU time, for example, right around there, around there, and around there. It's going to tell you exactly what happened. And then there's going to be a roll up at the whole fragment level. And absolutely right. Can tooling take all that and make it look prettier? Absolutely. But it's pretty easy. It opens up and search for the phrase CPU : space, and then just kind of hit next, and see these things really fast and go, oh, what happened here? Why is this one so much bigger than something else? Yeah. Hopefully that helped a little bit. Perfect. All right. I told you this just now. This is a stage, a fragment. It just happened to be a source one. Reads it from a data set. And if you remember, I said those circles that were the operators. That's an operator, scan, filter, partial aggregate, project. These are the things, as I was trying to say, this is that really weird kind of, all this is super parallel, but this is the place where it's not all that parallel. It's a sequential set of steps that I can do on every single record. And then someone else can, in a parallel way, work on another set of records and then someone else. This is just those things that I do record by record by record. And yes, for you really deep people, of course, we're doing vectorization and all these other things. So we're not, going to the source. We're doing chunks of things and working through them and then grabbing another chunk and stuff. But these are those things I said fit together. Those are the operators, or referred to as a plan node detail here, or I call them fragment nodes. But read. So this one says scan, filter, project the orders table. Read it. And there's a few other things I'm going to talk about. These things. There's some indications of other things happening here. I'll come back. So it reads those records, gets rid of the rows, the columns it doesn't want. It runs that filter that says, hey, look at the order date, make sure it's in the whatever. And then it says what? You might think, and in my drawings, I said, we're kind of done. But I'm going to show you, especially next time, the way we do things like group bys. We actually don't shuffle everything. We actually do a little bit of a partial aggregate. Old school people would call that a combiner. If you're around in the early MapReduce days, same kind of thing. But nonetheless, I'll show that with real data when we get a little bit later. So there could be a whole bunch of things here. Like everything else, you read from the bottom up, go to the bottom fragment / stage, and then go to the very bottom of these indents. And we do use indents here, which can kind of help us. So this happens, and then this, and then this. All right, fragment structure has a bunch of operations. What are some other things? Layouts. More of those things I kept talking about. Everywhere, at every step of this, there's a contract. Hey, I'm reading this. I'm giving you that. You're getting this. And so that's kind of what it says. It's like, hey, I'm reading these columns, but what am I doing? I'm sending a layout. So, I'm reading these. I'm sending these. This guy says, okay, I'm getting that, but what am I sending? Well, he's actually sending more of a hash map. And then what's that guy sending? They're just repeating everything. Probably the one that matters the most is right around the top where it says output layout, output partitioning, this space, right? If you can see my cursor kind of wiggling around here. This is where probably, if you just want to say quickly, what is this thing producing? It is producing, of all things, a hash map of customer key and then some other thing in there. You can kind of dive a little bit deeper in there. It's pretty much just a count, I think, is what I'm seeing there. And that's it. That's what he's producing, but it's at every little step as you go down. All right. I know everybody wants to run queries, and we're going to run only one today. I'm so sorry. I just feel I've done this enough that I feel like it's better to say these things instead of just run into it. But, you know, this is my strategy. I hope it's working out. Okay, what are some other things? Estimates. Estimates really will be noticeable here in that those source stages, right? When we read data. And they're really only going to be present if there's some kind of metadata, some kind of statistics that the engine can make choices about. So he's saying, oh, I think there'll be this many rows, the width, the depth, how much data size will that look like, and those kinds of things. And in fact, if you don't have a lot of estimates, let me see if, if you don't have a lot of estimates, I'm sorry, if you don't have a lot of statistics, in that very lowest level, you're going to see a lot of those question marks. And that's a quick indicator. In fact, remember I said earlier, hey, your query stinks. And I say, do you have current statistics? And you go, oh yeah, I run them once a day, Lester. And I go, well, can we run them again? You're like, they're there. And I go, So I say, fine. We open it up. And if I go to the bottom and the first thing I see in that very first estimate at the very bottom is a series of question marks, I go, well, we need to calculate statistics because there are none. The system is not grabbing them for some reason. Could they be wrong? Yes. Could they be incorrect? But the question marks will show up. And what's going to happen as you really read a plan, you're going to see the further we get up in that stack or walk in that directed acyclic graph, a series of stages toward the top, is we are going to start seeing more and more question marks as you go further and further because we don't really know yet what's happening. And that's kind of a rub all the engines do. Once you start saying, I do here, I'll do here. And everyone attacks it a little differently. So I'll leave that for Q&A if anyone wants to kind of discuss that. But today I would say we're a static planner. Some engines, the Spark engine several years ago introduced a concept of kind of like a replanning. They call it adaptive query execution. If you run a query in that model, it says build the plan, but only run so far, and then take another view at rebuild the plan from this point forward and rebuild it. And we don't do that necessarily. We have some strategies that will look like that are in the works, but we don't do that approach. All right, so question marks are the statistics, the estimates. These are the reals. Hey, you told me, I thought there are going to be this many rows, but what I really found was this many rows. Or sometimes it's just that, we were able at runtime to figure this out yet a little bit better. Often these are going to tell me, it depends on what version. These are an older version of snapshots here, but these connectors do get more love, week over week, year over year, all that good stuff. So some of the connectors are getting richer and richer and get smarter and smarter constantly. But ultimately, he's going to tell you exactly what he was able to read. He was able to read, 500,000 instead of 1.5 million. Yeah. Why? Well, we'll find out in a minute because it used a partition called order status. And we'll see that as we go a little bit further. So estimates, schedule time, and the biggest ones are really going to be the CPU and then amount of data that lifted. There's going to be some other things in there that probably aren't as filled out as much around networking stuff that to me seem like they're more like placeholders for if we can do better in that space, or maybe have some resource management in place that stops that. Okay. All right. So what are you going to see in that plan? Someone said, are you going to see these prunings and predicate pushdowns? You are going to see them. Sometimes they're going to look a little different connector by connector because the connector is the one that actually does the reading, but everything after the source connectors will be extremely generic. So let's just touch on a couple of these and run that query here because it seems like I'm taking longer than I want. An important one is things like column pruning. How do you know that I got a table with all these columns? How do I know that what was really read? Well, this one, if you look at it, he's doing a group by order status and some kind of operation on the total price. So really, it probably just needs to read the order status and the total price. So that's what we're seeing. This source says, hey, way down here, that's all I can read. Now I'm going to go to your secret. That's working because that's not a CSV. That's working because it's a column or file format that can allow us to retrieve that. If you read a real CSV record, it's going to say I have to read everything or JSON. And then, once I pull it across the wire. So why are we asking this? We're going to read less if we have 100 columns and we only need 2 columns. These are simple things where, JSON CSV versus Orca Parquet are dramatically better, faster because they can do partitioning. Column pruning. So this is a way to kind of see that happened. What are some other ones? Predicate pushdown is going to be definitely a scenario where it depends on the connector. And this slide, I did not build it. And I don't necessarily think I should have showed this one, but it's a good one. It says, hey, this connector is actually a Postgres connector. So that query ultimately somewhere in there, buried in there, and it's actually showing up down here. He's going to say something like, hey, this is the way he's telling you. You probably like, why don't I just see that query? It's up to the output, the programmer that built that one particular, but it is saying, hey, look, for this particular case, I actually did push that where clause down into the query that I sent to Postgres. But if it was a data lake, it could be more like the fact that you had a criteria and that connector. So if it was an iceberg connector, it's going to tell you in there, hey, I see this predicate, I see this range, or I see this in clause or whatever. And that's going to be clue to us that, oh, it's going to use the underlying metadata that lives in the iceberg metadata. So it's a little deeper, and we'll really see the value on the amount of data that's returned. But it will indicate that it's doing something like a predicate pushdown for us. A really cool one, or one to be thinking about, is when you talk about partitions. So this table up here has a multi-tier partition strategy. It's a bad partition strategy. It's based on order status, which changes, so that's already bad. And order status, which is there's not a lot of order statuses, so it's not getting the really lifting. So it's a terrible partition strategy. But with that said, when someone did run this query and they had order status equals F, what this is showing is it's going to list every time there's a partition down there in the column pruning, it's going to tell you very explicitly what was read, what I'm going to have to read. And this just says, again, it's bottom up. The bleeding tier is the order status. It says, hey, I'm going to look for a folder called F, because they are called like F and O and C. They're terrible looking smart values or something. And then it says, oh, there's a lower level part. Well, it looks like I'll have to read all of these, urgent one down to not specified and low. So what you're going to see in there is a listing either of a specific entity, like you see F, a collection of values, or a range. And usually when it's more of a number or a date, it'll say something like, if those order priorities were just like 1 through 5, it probably would have said, hey, I'm going to look for folders that are in the range of 1 through 5, or if it was dates, this day to this day. But that tells us pretty quickly, good, we're taking advantage of that strategy. And another thing I'm going to look at when you run your query is slow. I'm going to go look at that really fast. It's where you can look at your table. And if I don't see any mention of partitioning, I know you don't have a partition. I'm going to say, well, that's start 1. Start 2, if it says I'm reading everything, I'm going to go, do we take advantage of it, that kind of stuff. And again, we'll see that next time when we run through there. Aggregation pushdown, again, same thing I said about databases. So if it was a database, it's going to write it however that connector wants to do one. I think this one's still a Postgres. But if it was an iceberg one, we get a lot of aggregate pushdowns, not the exact same way a database works, but those files, those metadata files that are out there have aggregated values already calculated for us. So sometimes we're just lifting and shifting. So we're going to see some indication based on the connector type that's there. All right, 2 more things, and then I'll run a quick demo, and then we'll plan for next time. Joining. If you remember, if you were here, if you didn't give up on me today and you're still here, if I'm going to do a join of orders and line items now instead of orders and customers, okay, then what I said before is, hey, there's probably going to be, let's turn my pen on here. There's probably going to be a stage that reads one of those tables, and then another stage that reads another one of those tables. And both of those are going to do their shuffling exchanging to where a third stage that does the join. So think of those 3 boxes, not those 4, because this is saying, yeah, it could have been done a little bit differently. Scan, join. So there's 3 stages. And what you're looking for in the bottom here to verify that really, really worked. And sometimes, why am I looking here? Ordering matters a lot. Remember, we talked about bigger versus smaller and those kinds of things. And again, I'll show you this more next time. I'll run some queries just like this. But if I look really close, my hope is I see 2 fragments that say source. There they are, source and source. If I look really hard, I hope both of those say things like, hey, this one's going to read the orders, this one's going to read the line items, and they're both kind of independent of each other. I see estimates, that's good. There's statistics, etc. But what are they both going to do? They're both going to, right below there, it says output partition is. They're both going to emit or exchange a hash. They're going to hash the data. Hash it by what? The order key, because the order key is how they're going to do their join. And then what we're going to say is, okay, those are running. They're getting sent. Where are they getting consumed? Well, they're getting consumed in this stage up here. It's getting data as a hash. What is it getting it from? Well, it's getting, remember we said remote source is the trick. There's remote source number 4, which is this guy. There's remote source number 3, which is this guy. So he says, I'm bringing this one in. And in fact, this order matters. We want to read the smaller one first. That's how we expect this happen here. We're hoping the smaller one's there. And how will I know if that's right? Well, 4 is the orders. 3 is the line items. Probably there are more line items than orders. So good. They seem to be coming in the right order. Why? Because at heart, under the covers, it kind of acts like a miniature broadcast join. It's going to call what they call a build versus probe. More details than we want to get into today. But what we're looking for is where it says left and right. We're looking for one of them to be much different size, much smaller. We're hoping that the build one is a lot smaller. The build one is this 937,000, and the other one's 3.7 mil. Why will that matter? Another day, another longer conversation with you. But if they were flipped, we're going to see worse performance. And how do we know to get them in the right order? You could write your SQL in case there's no statistics. You can write them in the correct order and it'll pick it up in the right order. But maybe do both. Put statistics first, because telling every user out there which way to put their, which table to put first, the old bigger to smaller kind of strategy is good, but history says users don't think about that kind of stuff. Or my son's data analysis class said it doesn't matter, and it doesn't if everything is working good. Okay, we got 3 minutes left. I want to show a demo, so hang with me. If you got a few more minutes, the time will probably stop. If you have to run, I get it. Thanks for your time. Come back and watch these last few minutes if you can. Yeah, let me just show you that if we did a broadcast join, and this is the same things, orders and line items. If the system realized, hey, you know what, orders is small enough it can fit into memory, then we're going to expect the stage right there. We're going to expect the stage that says, hey, I'm a source, and I'm reading those orders, something small. And if you look at all the numbers, it'll tell you how small it'll be and all that good stuff. And you're expecting it to do what? Output it as a broadcast. So this is actually where now we have one stage, and then we have 2 stages. And there's no real exchange like we saw before. We're going to push all the information from orders to multiple places. If I have 10 machines in my cluster, it'll get pushed to 10 places, but that's it. So it's going to wait and then run this stage. It's a source stage. It's reading from the line items table, but before it does all that, it's going to get that remote source number 3. I should have done highlighting, right? Remote source number 3. Why? So it can do what they call a local exchange. It puts it into memory, and then it says run in parallel, read the line items. And because I have that in memory, I can do a join right then and there. Read a record, do the join, read the next record, do the join, next record. And we skipped that yucky broadcast, the yucky exchange that moved all the big data twice. And we did one less stage, and so good stuff that we'd expect to happen for us there. Yeah, yellow might look better. All right, I'm running out of time, so I'm gonna turn the page and say, guess what? We already saw there's graphical views of all that good stuff as well. Back to what we did the very first time. There are, if you really, not today in our Starburst UI, but in core Trino UI, you can do a live plan. You can actually see that plan in the numbers showing exactly what's happening right then and there. That'll eventually, for Starburst lovers like me, we'll eventually see that in our UI as well. But if you want to get that during runtime, you have to kind of go and get to the Trino plan. And then what I promise with 1 minute left is I'm going to say, next time, if you choose to join me after all this, you come back and I'm going to say, let's do, I have a bunch of queries, but I'm going to run a particular query today real fast The one you saw earlier there. I'll run it again just to have it fresh. And the goal for the end of next week is to be able to do what I'm about to do now. So I'm going to come here and say, hey, I look good. I had about 7 stages. Yep. Okay, great. Good stuff. There's the query plan. Let's go look at it. And I'm going to tell you what that query did. So let's look at the query one more time because I think I forgot that. So we're still live if you're here. If not, thank you. But we're still recording. If you look at the query, I missed it. Go back to the query editor. There's the query, right? Joins across 3 tables, and orders on Postgres, TPCH customer, and then a data lake nation key. Just builds them up. And why? I'm going to ultimately group by the full nation name that all the orders are coming from. Why? I'm trying to find out how many orders came from France, Russia, Mozambique, and Romania, so on and so forth. And they're very evenly spread as a generator. So So we ran all that already. And what should I expect? I expected to finish up 30, 60, 90 done. I hit my query details. I go to my advanced. Again, the goal for next time, not for you to perfectly follow me, is to go, oh, here it is. There's my fragment 0, the end of the line. I scroll to the bottom. I say, yep, 7 fragments. And then what am I going to do? I'm going to read this real quick with you. Hey, it's a source stage. Makes sense. What is it reading? It's reading the nations table. That makes sense. That's the smallest table. There's my estimates. It's really small. There's only 25 rows. This took about, 15 milliseconds to do all that. That's a lot for what it was doing, but okay. Probably latency time. It read basically nation key, it read 25 rows. Great. And what did it do when it was done? It broadcasted out that set of data, the little table with those 2 fields. Boom, nation key, nation. That's done. Okay, I'm going to look up higher, fragment 4. Okay, this is a source fragment. Okay, well, I'll read it from the bottom up. It says, hey, look, I got data from number 6. That's him. What is data from number 6? Those nation keys. Okay, he made sure that's in memory. That's all that says there. And then what did we do? Well, this is where we're going to looping. We're going to say, hey, what if I read the dynamic? We're going to read the customers table. And in fact, this thing did a dynamic filter. The thing I was trying to mention a little bit earlier. So it's actually saying it's waiting for this to finish down here to say, and this might have been overkill because we really needed all the nation keys, but there was only a few records. So the optimizer, everybody's going to work itself out. But nonetheless, it did do a dynamic filter, which seems a little weird. But he said, hey, read all those in massive order. And every single record after I read it, do what? Do a join. I have, what am I reading again? I'm reading a customer. So this customer has a nation code. So add it, add the nation name, USA instead of 4, whatever. That's really all it's doing. So it's pulling all that together. And then oddly enough, when it's done, it says I'm going to output this via a hash. I'm going to do that exchange. I'm going to figure out, make sure I send all customer key 7 to the same place, so on, and so forth. Okay, so he's done. Fragment 4 is a source, so he's going to read some data too. What is he reading it from? He's reading from Postgres, the orders table. He's using our dynamic filters. He's actually using a cus key. He's not given an end clause. He's given a between clause. Hey, read records where the order ID, the customer ID is between this and this. Maybe in my system I'm getting everything, but it is still being dynamic for us. And there's that dynamic filter. These ranges from 1 to customer number 150,000 or something. And really, you might think, okay, he's going to exchange that to my next guy, but he went ahead and said, you know what? We're doing a count. Ultimately, we're going to do a count on how many orders that happened for a particular nation. And one would argue, you know what? Instead of me sending every order out, why don't I intelligently, as I'm going, keep my own counters? So he's doing what they call a partial aggregate. He's starting to roll up of the slice he saw, the split he saw. How many orders did I see for US versus Russia versus whatever? So it's not going to be the comprehensive answer, but it's a short enough answer. And why is that important? Because I will get to send out, when I hash, I send out a lot fewer rows out of here. A whole lot fewer rows. How many rows? I think specifically, I think I should see it. Actually, I think it says something like 1,500. There are not 1,500 nations, but there are a bunch of splits. So each split is sending out the distinct number of nations, which is about 25. That's a good thing. It's actually doing some more smart stuff. All right, so what else do I have? Another source, because remember, this one actually says This is a funny one. It says, I'm reading my data, getting it from a hash, but if you look really, really hard, it's actually, no, this is not a source. We read all sources. He's actually saying, I'm getting data from 5. What's 5? 5 was this guy. Getting data from 4, that's from this guy. He's basically doing all that. Why? He wants to do a join. This is where the actual join is happening. And it went ahead and did a little bit more of that partial aggregation. Again, the whole reason it's doing that is to send less data from the exchanges. And I got 5 after, so let me finish her up. This guy says, I'm pulling all that information. I'll finalize. This is the actual great. We can finally trim it down to right here, an output of 25 rows. So the end of this, there's only 25 rows at this point in time. So this is going to get really fast. After this, these are the counts. They're just spread around. And then all I want to do is sort it by the counts. So just to let us say it next time in more detail, these last two steps are going to do sorting in a distributed fashion. So it's going to do what they call a partial sort and then ultimately a sort merge. This one had 25 records. You could argue it doesn't need to do the partial sort, but I'll explain next time why that we just always do the partial sort, because it's better to have one piece of code. And if you look really close here, it takes, 29 milliseconds. And so doing all that took no time at all. All right, that's what I want to kind of walk through next time with all the foundation knowledge we did from visualizing all this, the syntax that we saw today. So if you're new to this, and you're watching this live, it's number 3 time. Well, you know what I mean. These kind of all build upon there. I think the thing that everyone wanted to see was session 3. I made you wait. Thank you for your patience. I'm looking forward to see you on the 16th or in the video recordings if that's where we see you. I'm going to hang around in case there's other questions, but we're officially kind of done. All right, Brent, I see one. So thanks again for staying late if you did. The questions are still rolling by. Let me see if I can make. Okay, good. Brent, is it possible to provide hints to use the broadcast? The short answer is no, Brent, on the broadcast. The trick is if you see that the broadcast did not occur and you know it should have, or you believe it should have, you have a couple choices here. You can kind of say, well, what's my threshold for what fits into memory? Usually by default, it'll be like 100 meg. You could say, hey, this has been running all the time and it just stopped doing a broadcast. So a quick fix might be just to bump that number a little bit as a session variable, say session 110, 120, nothing that'll blow the system up, but get you over the hump. But the real work is going to be going back and saying, what's changed now? Probably what happened is your data finally just slowly got bigger and bigger and it crossed some threshold that says, it's too big for a broadcast now. Can you fix that? You can raise the level, or you can go back and keep looking. Can I put more where? Can I do more projection and filtering on the table that is being broadcasted? Is it reading and sharing too many columns and too many rows, and that will ultimately probably get you over that hump. So it's not a hint in this system. In fact, I think that's there. All right, cool. Thanks, Brent. Thumbs up. All right, again, I'm just going to hang on a couple more minutes. Hopefully, we'll cut this part off if there's no questions. I see that makes sense. Thank you. And Monica, unless you heard something else, I'm going to wait 3 or 4 more seconds here. I think we'll just shut her down. All right. Oh, there we go. I saw a question or two. Hold on, Monica. Let's see. Do you need to consider performance on the source system? Yeah, you do, Randy. And I think that's a multi-loaded question. Randy says, do you need to consider the performance on the source system? That is a whole bunch of questions in one. Couple questions. Yes. If this is a data lake, then how you lay the data down is going to matter. What kind of table format? What kind of file format? Did you use partitioning or not? Is it total order sorted? All that will matter. Make things better. We have a whole other set of webinars and sessions around what are those patterns and strategies. If it's an Oracle system, same, just Teradata. But I would say what really consider when we talk about things that are not the data lake itself, so the connectors like Oracle, Teradata, Salesforce, Kafka, Elasticsearch, we can't arguably make that system go any faster than it already does. But we are going to look at what we're doing and decide what information and what questions we ask of that underlying system. So ultimately, I guess what I'm trying to say is if the CBO itself or you, because you can do a hint on a connector that goes to the database and say, just do it, just send it to the database. If for some reason the entire query in mass just gets sent down and returns back, yeah, the performance of that system will matter because we are now just a man in the middle, and we're going to be adding a little bit of overhead by the fact that you came to me and I went to this system, the system gave it to me, I gave it to you. So the performance ultimately in all different perspectives will absolutely matter. Yeah, we're going to touch on that, Brent. Next time, the plan might show me that my data is poorly optimized, small files, bad part. Yeah, I'm going to show you examples of all those right out of the gate. Yeah. Or good partition key and you didn't use the partition or all that stuff. Yeah. So I know everyone in wanted session 3. So I'm going to see you. I'll see y'all in 2 weeks. I'm going to go to Italy with my wife next week, but I'll be ready to go in 2 weeks. See y'all back here. All right. I'm going to go ahead and count to 3 and push the button. Monica, thanks for hanging around with us. And everyone have a great day. And we'll see y'all next time. Bye-bye.